To stop climate change, we need massive amounts of clean electricity. Nuclear power provides constant, carbon-free energy, but building traditional plants takes decades and costs billions of dollars. Today, we are exploring small modular reactors, or SMRs, a new class of factory-built nuclear reactors designed to make clean fission energy cheap, safe, and portable. Traditional nuclear projects are financial risks. They are massive, custom-engineered structures built on site. Any construction delay, weather issue, or regulatory change can cause costs to skyrocket. With average build times exceeding 10 years and capital costs topping $10 billion, utilities simply cannot afford to build them anymore. SMRs represent a paradigm shift. Instead of generating thousands of megawatts, they produce up to 300 megawatts. Instead of building on site, they are assembled on a standardized factory line. This allows them to be built in under 3 years and shipped directly to their destination by truck or train. The magic of SMRs is factory standardization. Building a reactor in a controlled factory is faster and more precise than building in the rain and mud on site. While the site is prepared, the reactor is built on an assembly line. This modular approach reduces construction risks and guarantees predictable timelines. SMRs use passive safety systems that rely on the laws of physics rather than human action. If a problem occurs, gravity automatically drains emergency water into the core. Natural convection circulates the water as hot liquid rises, and heat is radiated away through containment walls. The reactor cools itself indefinitely, without power. SMRs have a tiny footprint. The entire reactor vessel fits on a flatbed truck. Because they are compact, they require a fraction of the land area of conventional plants. In fact, they can be installed at retired coal power plants, reusing the existing transmission lines and saving millions of dollars in grid integration costs. SMRs enable decentralized energy networks. Instead of sending power over long distances, we can place SMRs directly next to where power is needed. They are ideal for remote mining sites, chemical factories, and AI data centers. If a facility expands, operators can simply plug in another SMR module to increase output. The financial math is compelling. A traditional nuclear plant requires a massive $10 billion upfront investment. A single SMR module costs around $1 billion. By reducing build times from 10 years to 3, developers save millions in interest expenses, making SMRs accessible to smaller utility grids. Despite their benefits, SMRs face regulatory hurdles. Licensing systems were designed for large reactors and struggle to adapt to modular designs. Getting a design approved takes years and costs millions of dollars. To deploy SMRs globally, nations must coordinate safety certifications to allow factory-built modules to cross borders. SMRs are entering service. China has connected its first modular high-temperature gas reactor to the grid. In the West, companies like GE, Hitachi, and NuScale are partnering with utilities to build plants in Idaho and Canada, proving that modular fission is transitioning from concept to grid reality. SMRs still produce radioactive waste. However, because they are sealed at the factory and refueled less often, fuel handling risks are minimized. Some advanced designs can even recycle spent fuel from older plants. Nonetheless, building deep geological repositories remains a requirement for long-term storage. Small modular reactors are transforming nuclear power from a slow, custom megaproject into a standardized, factory-built clean technology. By utilizing passive safety and flexible scaling, they offer a realistic path to supply carbon-free baseload power. What do you think about SMRs? Let us know in the comments below. If you want more simple science explanations, subscribe to Layman's Field, bringing knowledge for everyone. We will see you in the next video.